When constructors were created in JavaScript, the idea was to create something similar to how OOP is used in other languages. However, there are things people don't like about constructors. For example, the way you work with the prototype in order to include inheritance, or the extensive use of the this keyword. So with JavaScript ES6, classes were added to the language, and that is what we'll look at now. There's one caveat I want to throw out before we look at this. If you are coming from a traditional OOP language such as Java or C++, classes will look similar, but they don't work exactly like those languages. We are still using JavaScript with prototypal inheritance, so it is important to learn JavaScript classes as their own thing. Because of this, some developers argue that the traditional patterns for making objects is better because it uses JavaScript as JavaScript and doesn't try to pretend it's something else. Despite that, classes are used extensively in newer code. But you need to decide which pattern is best for you. Just make sure you understand them all because you will see them all. All right, with that out of the way, let's jump into it. So I'm going to create a class of the same information once again, meaning room, and I'm going to do it with this already here, with the constructor code already here, so you'll be able to compare it. So let me go down here and we'll begin setting that up. So the way we begin setting up a class is with the class keyword, and then we name that class. So I'm going to name it meeting room like I did before. And then everything about the class is contained within those curly braces. So that's one of the nice features of the class construct, is that we keep everything in one place. That wasn't true with these other patterns. As you can see, we have the constructor function up here, then we have other stuff added to the prototype down here. So things were spread out. But with the class constructor, generally, we can keep everything contained within these curly braces. Now, when setting up a class, one of the first things you'll want to create is a constructor. And we do that with the constructor keyword. Now, this particular function is called every time we instantiate that class. And what do we mean by instantiate? Well, that means creating an instance of the class, which is creating an object. So instantiate is a term that comes from traditional OOP. And so every time we instantiate a class, create an object from it, it calls this constructor function. And so this is going to do very similar to what our constructor function up here does. So we're going to make it the same. We'll put the name, capacity, we'll have those same parameters there that are going to be passed in. And then we set our curly braces, and now we can do whatever we need to inside this constructor function. And basically, we can copy everything we have up here. It's going to be exactly the same inside the constructor. Let me just indent those. And so there we have our constructor of our class set up. So now if we were to go ahead and save this, we would get instances, objects created for boardroom and training room. All of this stays the same. We still use the new keyword with classes, and it creates an object. But we also want to add the reserve method. Now, as we did with the constructor function, we had to do that separately. Well, we don't need to do that with the class construct. We just come below this constructor here and we begin adding whatever methods we want. Now, these are going to be added onto the prototype. So that's what I mean by saying that the class construct doesn't work like other traditional OOP languages. So this here, this reserve method I'm creating, will be added to the prototype. We'll take a look at that in just a minute. I'm going to put the same parameters there and then just define this. In fact, I can just use the same code I got up here to define that. Just put that down here. And there's our reserve method added to our class construct, added to our class. Now, once again, re-emphasizing, everything's kept within these curly braces, so don't have stuff outside of it. Now, let's go ahead and take a look at it at this point, but first I want to comment out everything I did up here for the constructor pattern. Just comment those out. Save this, and I'm going to reduce our window a little bit there so we can get to this and then open the console. All right, let's take a look at Boardroom. Let me open it up. So we created an object. We use the exact same code as I mentioned down here to create the object as we did with the constructor function. Exact same code, and it created an object for us, Boardroom. And if we look at the prototype, we open up that prototype. Notice the reserve method is here on the prototype. So it's not doing anything different. It's just what we call syntactic sugar. It allows us to use something that looks like classes in traditional OOP to set things up the way JavaScript does it. So we still have inheritance. We still have encapsulation. Those primary elements of OOP we're still doing, and we're doing them in a JavaScript way, but using the class construct. All right, now, what if, let me jump back here to the code. What if we wanted to add a property to the prototype? We added a method to the prototype by simply putting it here inside the class. But if we want to add a property, we're not able to just add a variable down here and have it do the same thing. That doesn't work. And so if we need to add something like this, how would we do it? Well, interesting enough, we do it exactly the same way. And so this deviates a bit from that whole idea that everything's going to be contained within the curly braces. But it's only when we need to add a property to the prototype. And if you need to do something like this, you need to understand this is how you do it. So we still go meeting room.prototype and then whatever the property name, and then we add the value. So let's take a look at that. So if I save that again, this time we'll look at training room. And if I open that up, have our stuff on the front here, and then we open up the prototype, we can see we now have a property associated with prototype as well as the method that was already there. Now, as with constructor functions and as with factory functions, if we want to change something on every instance, if we want to change the way the reserve function works on all of these objects that are created, we simply change it here in the class. We could add another line of code here, change it here. Since it's on the prototype, it would change it there. It would affect all of the objects. Now, one last thing I want to mention before we move on to our next topic, and that is the use of the keyword new. As you can see, that's required. Now, if we did not use the keyword new, if I remove that, save this, we get an error. Class constructor meeting room cannot be invoked without new. It tells us specifically what the problem is, which is a nice feature with the class constructor. Now, that is not true with constructor functions unless you're using strict mode, which is what I did. I used strict mode when we were creating the constructor function. And because I used strict mode, if we would have left the keyword new off, it would have given us an error as well. And the reason it does this is because with strict mode, the keyword this points to the wrong object or an undefined object. And so we would get an error when it tried to assign something to it. So that's an important side note to be aware of when using constructor functions, is you want to use strict mode when working with those. Now classes, by default, classes use strict mode in its code. And so that's why we are getting an error if I delete this new. It automatically gives us that. All right, let's move on to the next topic.